Hello, everybody. It's great to be here. So I'm David Bleackley, and I brought with me my digital twin, Steve Williams. Why is he a digital twin? Well, at one level, he looks very similar to me. He's dressed in grey, 2 arms and legs, 1 head. Good start. But the one thing that Steve has, he has more information and more knowledge, and he's better at putting it in context than I'll ever be able to. So I'm going to do the pretty part of the presentation, and Steve's going to take you through the interesting bits. So, that said, what is digital transformation? If I ask everybody in this room to write it down on a piece of paper, I'll get 440 different definitions, I'm sure. So for the sake of the next 40 minutes, I'm going to give us a definition to think about and to work on for the purpose of this discussion. So to me, digital transformation is all about enabling improved decision-making across an organization or a business unit or a whole enterprise. And why is that important? Because if we want to drive change in our businesses, we need to drive change across the organization at scale and at pace. And what we're going to talk about for the next few minutes is how we do that through the engineering life cycle. So a brief history. This is Exchange 27. At 26 last year, we introduced the concept of AVEVA and Schneider software business merging. So one of the things I've been asked to talk about is the history of AVEVA. Now, I can talk for hours on this. I'm not going to. Just to say that we came out of Cambridge University in the UK over 50 years ago. We started there because they had the powerful computing capabilities that we needed to render complex graphic environments. And over that time, we've made many advancements and been first in many areas of our business. And now, with joining together with Schneider Software, we've got a real opportunity to create transformational change again, because we can bring together the physical digital twin together with the operational and behavioral digital twin that Doug referred to in his presentation this morning. So we're going to walk through some of that now. Just to say, AVEVA, forgetting the 26 years past, has a large install base of many clients, many tier 1, tier 2, and small customers as well, spanning all industries from EPCs, oil and gas, chemicals, petrochemicals, food and bev, mining. So we've got a broad experience from the AVEVA heritage as well. So we understand those assets, we understand how those assets are designed, built, and constructed. So, what is our concept of the digital asset? We believe that for every physical asset that exists or is under development, there needs to be a digital representation of it, a true, rigorous digital representation of that asset. And that might...
Our customers are creators. They keep things moving. They make our world run smoothly, efficiently, and safely. They make the imagined reality, the impossible achievable, in an environment that's changing faster, growing tougher, and increasing in complexity. And as challenges grow, technology has to meet them. But horizons must be expanded without creating risk. The consequences are too great. We understand our customers, the immensity of their projects, the intensity of their pressures. So we enable them to visualize a project in its entirety, from the big picture down to the smallest detail, and to keep track of the seemingly immeasurable. To manage this breadth of scale, we push boundaries in the digital world, where everything is possible. To stay in the lead, our customers need to see the world differently. To understand the deep continuity between design, construction, and operations. And to control this continuity so that the digital and the physical are identical. The one constant is the need for change. Change driven by new demands. Change driven by the desire to do things better. Change driven by sustaining what you've created. We enable our customers to master change. We make life easier for them, so they can focus on their core business and continue to make the world run more smoothly, more efficiently, more safely. One more reason why our customers benefit from the support of a company that shares their vision and understands their values.
So in the top corner of the screen, you'll see the engineering information, and that's what we're going to focus on that comes from the AVEVA portfolio. But next to it on the top left is process simulation, and that comes from the Schneider heritage. And it's bringing these two things together that is one of the drivers for bringing the companies together, because it allows us to accelerate and de-risk capital projects through that integration. And we'll touch on that as we go through the presentation. So an important concept is that we need to keep that digital twin alive all through its life cycle, from conceptual design through the construction phase and into operations. And Steve will elaborate on that a little bit more. To be able to develop a meaningful digital twin, and therefore to enable us to transform our business processes in the engineering space, we need to build an infrastructure, a platform that allows us to get information in a trusted way through calculations and tool methodologies that allow us to design in a consistent way, enabling you to use your best practices, your company best practices, and industry best practices in the process design, mechanical design, and all the other disciplines involved. And then we need to be able to share that information across multiple disciplines so that consecutive and consistent decision-making can be made across the organization to drive that business transformation that we're looking for. And one of the key things, and we've seen many examples of it already this morning, to enable that is visualization. We're instinctively visual creatures. It really helps our thought processes for many of us to actually see what we're talking about and to have a common view of what we're talking about with our peers and our colleagues. We're not imagining our own view of the world and what it means. When you can share that same interface and share that same visual representation of an asset, you can really start to understand the problems that you're faced with, be those design problems, be the scheduling problems, etc. And within the AVEVA portfolio, we've built over the years, over the last 50 years, both in the AVEVA side of the business and the Schneider side of the business, we've built these applications. They're proven and trusted applications. So from the Schneider side of the business, where's my little pointer before there we go. From the Schneider side of the business, we brought these process simulation tools. And from the AVEVA side of the business, we go more into the detailed and mechanical design through a series of mechanical design and engineering design tools, through into materials planning and construction, contracts management, and ultimately into fabrication as well. And then as we move into commissioning and startup, we have a range of operator training tools and learning management tools to help people bring that plant to life, commission it, start it up, make sure your operators understand the behavior of that plant as well as the mechanics of it. and that ties in with the presentation we had before the break. So I'm now going to hand over to Steve, who, this is the intelligent part of the digital twin. Oh, he's already brought his own, that proves the point.
Okay, so thanks, Dave. So what I want to talk about today is essentially just to step you through essentially the core of the solution offering from the legacy AVEVA side. So it's probably something which is quite new to most people in the audience, but hopefully interesting as well. And this is essentially a suite of applications, a suite of solutions that allow us to do exactly what it says at the top there, to engineer, procure, construct, our physical facilities that we want to build. And this solution set is basically what AVEVA has been doing for 50 years, and we've been able to allow our customers to design, construct, and then go into operations with some of the world's largest facilities, in fact, the largest facilities in the world, whether that's a floating LNG platform, or whether that's an oil rig, or whether that's a nuclear power station, a thermal power station. We've got experience in designing and constructing these across the whole different sectors. And it basically steps through the process here, and we'll go through that. And simply, it's basically, we need to start by defining what it is we want to deliver. So we talk about digital twins, but if we want to deliver a digital twin, a digital asset, we need to actually have an understanding of what that means. We then go through the different tools and the project execution of how we build that digital asset, how we go from the digital creation into the real physical world, and then how we can take all of that information later on into operations. And so I'm going to step through each one of these and just explain in a little bit more detail about each of the different sets of solutions that we have. So the first point is that we need to understand what information we want to be delivered for our project. The reason for this is because we need to be able to validate information as it comes in. We need to be able to report on the progress and completion of our project. And we need to be able to understand if we're being delivered the information we need. So we need to ask, for our digital twin, what information is needed, when should it be delivered in the project, and who should deliver it. And this then forms the baseline for our validation, our progress reporting, something that we can measure our progress against as we create our digital asset. So this kind of comes into several points. We have our actual information modeling. So what is the data that we're going to put into our facility? We need to think about the configuration of how that data is built up over time. And then we have some information governance, which is that we can actually take all of this information standard, version it, and distribute that to the supply chain, distribute it to our stakeholders, so that everybody understands exactly what information they should be delivering at each point in the project as we go through. Now, when I talk information standards and we talk information modeling, what does that realistically mean? Well, it essentially means that we can define a whole hierarchy of all the different object types we're going to find in our facility. And we can define how they're going to be described digitally. So what data, what associations, what documents are we going to be need. And then we can layer on top of that when they need to be delivered, who's going to deliver them. And so this just creates this baseline for our project execution of all the information that we expect to be delivered. Once we've defined that engineering baseline, we then have to actually go and start to create some information. So this is what we call our integrated project execution. So this is, again, a suite of tools which are discipline-specific productivity tools. So they provide each discipline with the best-in-class capabilities to do their work. So we have 3D modeling applications, P&ID applications, instrumentation applications. But all of those applications are integrated together at a data level. That means that we can provide a true collaborative approach to our engineering and design, so that our engineers have all the context they need to make sound decisions. So as David said, it's all about improving decision-making. We need to give them the data they need, and we need to also be able to manage change in that data. So this integrated approach allows us to efficiently manage change across the project, which means we can have a single digital thread going from the first simulation run of how we think something may run all the way through to when we actually start and commission up the plant. It's a single way all the way through. And we have a real focus on providing people with efficient ways of working, both in terms of the individual tool set and the integrated tool set, to create correct and quality deliverables, so that what we actually construct is what we really need. So this, in essence, is what we call data-centric processes rather than document-centric processes. And this is really the key differentiator for what AVEVA do if you compare it to some traditional approaches. So instead of managing engineering documents, we manage engineering data. And we can transfer single points of data to provide context and targeted information. Because we're doing this as a data-centric process instead of a document-centric process, it allows us to create digitally connected data as users work. So users are working in a 3D model. What they're not doing is building up just a 3D CAD file. They're building up a digital representation of the physical facility. And this allows us to add value across the whole project lifecycle and transform processes as we go through. Now, these tool sets that we design and construct are basically broken down into two main areas. So the first area is what we call integrated engineering and design. So this is where we have all the different discipline-specific tools for creating things. So you can see here we have 3D models, we have P&ID applications, we have engineering data applications. This is actually a screenshot from a data application. So this is an application which is designed for managing engineering lists and registers. Traditionally, in the past, this may have been managed in Excel or something along those lines. But here you can see by using a proper digitally enabled tool, we can see the 3D, we can see the P&ID, we have a connected, contextualized image of our data as we work. And so these integrated engineering design tools allow us to build a digital representation of what it is we want to build out in the physical world. But obviously, at some point, we have to take that digital world into the physical and actually go and construct something. So that's where the next piece comes in, which is that we integrate that into our resource management portfolio. So we call this ERM, Enterprise Resource Management. And this allows us to take that digital representation, all the bill of materials, and go away and purchase them and construct. So it takes us through supplier management, RFQ management, RFP management, through supplier delivery management, site material control, construction planning, everything we need to do to take that digital representation we've created and turn it into something physical that we actually build as we go through. All this in itself is wrapped inside, obviously, contractual frameworks as you're building a plant. So we also offer a suite of tools that allow us to manage all the contractual arrangements around this project as well, so that we can start to make sure that any change requests are effectively managed and tracked. We can look at disputes and different things. So we have a whole suite that allows us to manage all of this process. And what this allows us to do is to easily make sure that when change happens, when we're designing, we don't have any knock-on effects down the process. So really simple changes in the design phase, if they're not captured, can have a really big impact once we start to get to site. And so what we're doing with our solution stack is to unify all of that data together, make sure it's consistent and complete, and communicate throughout the project lifecycle that data as we go forwards, to really improve the way that we can execute these projects. So that's how we build the digital twin. So this is the digital representation. These tools are allowing us to build that digital representation and make it physically in the world. But at some point, we're going to have to take all of that data that we've created in that domain and take it into an operational domain. So when we get into operations, we have the information from the design tools, but there's also a whole host of other information that's available. So we may have all the vendor documentation, operating manuals, this kind of stuff. So what we need to do here is to take that information and integrate it all together with the design intent. So we collect and integrate all the different sources of information, and we have some technology that allows us to intelligently link all of these things. So it scrapes all the different documents and different data sources, links them together to create a navigable web of information that we can go and validate and report on, but we can also search and discover new information. And it really allows us then to exploit all of this information that's being created and use it for making better decisions in operations. And this is a really key point, because this is where we can start to bring in some of the new technology that we have, and for my terms, in the Schneider Electric side, to really bring a full digital twin together. But essentially what this does is, and it kind of recognizes the fact that a single object in our facility is represented in many different digital ways, and it's always going to be represented in different digital ways. So we have a pump. A pump may be in a 3D model. It may be of a schematic. It may have a data sheet. It may have various different information sources. What our technology does is be able to look into all of those different sources and integrate them together to create this web of information. It's a connected network of data that we can navigate through. What we then can do is to serve that up to any number of different ways that we can access that. And the key thing with this platform is that we no longer have to have the source applications installed. So if we want to view a 3D model, for example, we can just view the 3D model. We don't have to have the engineering application installed. And this is a really powerful way of accessing information. It means we can put information to the people that need it, whether that's in the field, whether it's in a control room, whether it's anywhere that they are. And so what we can do is we can start to locate information, we can find information about different objects. When we find them, we can start to discover all the information that maybe wouldn't be available if we hadn't used this kind of tool, because we're using the computers to automatically find the information for us. We can view the information, whether that's a 3D model, whether it's even on an existing facility and we've got a laser scan, we can start to view that in here and see the information. Whether it's a data sheet, whether it's an Excel file, it doesn't matter what it is, we can view it in here. And importantly, it also allows us to report on that data. So where we created that information standard at the start for our project, we can now start to see if the data that's being delivered from our supply chain is matching those data requirements. Is it matching the information we actually need to operate our plant effectively? And we can do the reporting both graphically, or it could be in terms of dashboards and things like that. But this gives us the insights we need to take effective decisions and then action those decisions as we go through. And then finally, we've put all this hard work into defining the information standards. We've built the digital asset. We've built the physical asset. We've pulled all the information together. So why can't we now start to use some interesting and exciting technologies to allow us to visualize that data? So this is where we can start to use our advanced 3D visualization technology, or maybe our augmented reality technology, to allow us to exploit that information more easily. And this is all about breaking down the barriers to information access. Because we know if we go and talk to an engineer on site and you say you've got to use this complicated engineering application, they're not going to use it. If we say you can access this information through 2 touches on a touchscreen, then they may actually start to use it. And so it's breaking down the barriers to this information. And it's also using the 3D model to allow us to view complex data in a really visual and easy to understand way. So it may look something like this, where we use the 3D model as the access way into the digital asset. So in this application, similar to how Doug showed earlier, you can use the 3D model to find quickly what you're interested in, tap on it with your finger, and you're presented with all the information that's available to that. Whether that's documentation, technical data, real-time information, maintenance history, it's all available through one place. It also allows us to take all of the data about the asset and overlay that so that we can start to understand what our data really means in terms of the physical world. So this is an example of where we have commissioning data as we're bringing a plant online. We can start to really visualize which things and which parts of the plant are commissioned and what status they are as we go through. So just as a recap then, we can, this part of a portfolio allows us to define the information we want for our digital asset. It allows us to create that digital asset and turn that digital asset into a physical asset. And then it allows us to take all of that data and repurpose it for use in operations where we can visualize and provide access to all of that information. And back to Dave.
Thank you. So just to recap on what Doug said earlier this morning, what does this enable us to do when we go into operations, that true digital representation of the plant? Well, the first and one of the most important things is it gives you true situational awareness of what is happening in your asset and collective situational awareness. Many's the time when the guy out in the field is saying that there's an issue and the guy in the control room or the guy in the engineering office all have a different understanding of what that problem is. Through this technology, you can see exactly what is happening in your asset. You can understand the size of equipment, the shape, the relationship to it. You can understand access and entry points. You can understand emergency exit routes. And on top of that, you can layer in all these other operational information around where permits are active or they're planned. Are isolations in place? You can bring in your real-time information from your Wonderware systems in terms of alarms, events, history trends, etc. And through our asset management and performance portfolio, we can start to enable you to understand the asset's health. You know, is this asset operationally safe to operate? all the time you're operating an asset, it's never operating at its design point, or hardly ever operating at its design point, and you're at some point of deviation from normal design. Well, is it safe to carry on operating that? What's the collective view across your organization? What's the risk you're carrying in continuing to operate in that way? And what mitigations might we make to address that matter? This technology brings that together so you can all have that common understanding of what's happening and plot your path forward and make those executive decisions. I'm just going to go back. I'm going to now show two videos in the time we have left. This is from Southern Company. The first video is them explaining why they wanted to create a digital twin. And the second video is after the digital twin had been created and the results that they found from that. So I'll leave it to the client to talk.
The AVEVA solution that we chose was the Integrated Engineering and Design suite of tools. We embarked earlier this year on a very aggressive schedule to implement all of those tools together, which is something that, according to our AVEVA partners, isn't typically done. But we felt like it was the right thing to do, because one of the things that we feel like this technology will help us with is collaboration among our disciplines. And so we wanted all the disciplines to use the tools at the same time so that they can communicate with each other much better. And that was one of the biggest benefits we saw of implementing the IED suite. The team worked extremely well with us to implement the tools, and we've been very successful, and we're really excited about it. We're starting a production project using these tools right now. There were really two main distinguishing factors that made us choose AVEVA. The first one was AVEVA's strategy around using AVEVANet and Engage, their new Engage tool, to help facilitate the information, facilitate sharing the information with downstream processes, construction, procurement, startup, and operations and maintenance. And so that's a strategy that we, as an owner-operator at Southern Company, really wanted to embrace, and that was one of the main distinguishing factors. The other was really AVEVA's willingness to form a long-term strategic partnership with us. That's evidenced by quite a few of, or many long-term customers that AVEVA has. And that's something we wanted to do as well, as form a long-term strategic partnership.
For every Southern Company asset, vast amounts of information are created. We can harness this information in a way that will increase productivity, reliability, and most importantly, safety, by linking a digital asset to every critical physical asset at a plant. The digital asset captures and connects everything so that information is within reach, literally at your fingertips, in just minutes. Using the model for this Southern Company natural gas plant, we can now demonstrate the power of the digital fleet. Our demonstrator represents a system owner using the AVEVA Engage software to find information he needs quickly and efficiently. This information is current and comprised of data from different design and modeling systems, Documentum, and other sources, seamlessly integrated into one point of access. He is looking for PNIDs and vendor manuals for the boiler feed water pump to prepare for an upcoming outage. There are several ways he can locate this information. He can use the intuitive touchscreen navigation to locate the pump in the model. Anyone who has used a touchscreen device will learn to navigate the model within minutes. Or he can use the search feature by using the touchscreen keypad and typing in the tag name of the asset he needs information for. Once he performs the search and selects the asset ID, the system directs him straight to the pump in the model, where he now has access to all available information. Once the pump is highlighted, it's also isolated and can be viewed from all angles. A simple dialog box shows high-level information about the asset and also allows access to associated documents. These documents are accessible directly from the Engage system. They can be viewed and navigated in the touchscreen interface. Our demonstrator will now show that the system also allows a user to isolate and view whole systems by using visual queries. He can now isolate all assets in a particular train in his system and access the information he needs associated with those assets. Our demonstrator has accomplished in minutes what would have taken considerable time and effort using manual processes, older technologies, and multiple systems. The power of the digital fleet is literally at his fingertips, improving performance and enabling him to work faster, safer, and more efficiently. AVEVA Engage and other systems currently being evaluated or configured are the next evolution of software for construction, operations, and maintenance. They will take us from spreadsheets, binders, and disparate databases to an automated environment where we can manage an enormous amount of information at the touch of a finger. The future in engineering information management is here.
So, hopefully we've given you an introduction into the heritage AVEVA side of the company, and I'll just make it, just to be clear, I'll clarify that remark. There is no side of the company. The integration is virtually complete. The two teams are working together seamlessly across the business in terms of sales, technical sales, marketing, R&D. All those teams have been merged. Everybody's getting a common understanding of what this platform is, and we're behaving as one company, not Schneider Software and AVEVA. I think that's a key point to make. And as Doug referred to earlier, we're building the platform around these 5 pillars. But what hopefully we've shown today that the information management technology allows you to bring information and knowledge from those different pillars together into a cohesive decision-making environment that can help you drive your digital transformation. And that applies both through the engineering construction lifecycle, through commissioning and handover, and taking that digital twin into life so that you can understand the behavior of it as you operate your plants into the future.